Good morning, everyone, and welcome to a terrific Transformations Tuesday. Thank you for showing up for your learning. And to get started, very warm welcome to Mr. Feldman, returning to room 229. Fantastic to have you back. What an honor to have you back in the classroom. So for today, everyone, your schedule, the first block, we're going to go over a quick lesson on transformations of functions. Yesterday, we looked at working a table of values and converting those points point by point to do a combination of transformations. Today, we'll work graphically and use that method to check our work. So we want to move towards what Mr. Kushner was talking about yesterday, which is like a broader systemic understanding of what's happening, not just feeling like there's various numbers coming at us and we try and manage them as we can and use the methods that we learn, but more so to understand why things are functioning the way they do and to see the interrelationship between something like a graphical representation and working point by point with table of values. The homework for the first part is page 130, number 5, number 6, and number 8. And I will post a Delta Math assignment as well. It's going to recap your exponent laws as well as doing some transformations of functions. And then in the second part, you're going to have a work period on your choice board. Please have all the mathematical work done for me to give you feedback by Wednesday. If Mr. Feldman can give you feedback on that, that's fantastic too. So I'm really happy that he gets a chance to see what you're working on. I know there's some really exciting projects out there, and I wish I could be on the fly on the wall for some of those conversations. So looking forward to hearing how that goes when I see you all tomorrow. So yeah, all mathematical work means if you've got graphs, if you've got table of values, if you've got equations, have that ready in rough draft form before you go ahead and put that on your nice poster board or include it in your rap or your interpretive dance or whatever you're doing to embody this learning in a new way. Email me your questions. I'll be available to you throughout the day. I'm at home with a child that's going to fail the COVID test tomorrow. The screening, not the test. He's going to pass the COVID test. My goodness. Okay, so anyhow, let's go. All right. So we remember that there's only outputs and inputs to functions. There's only these two things. There's y's and there's x's. There's the value of f of x, and then there's x. Okay? And then we can do two things to those outputs and inputs. We can either multiply or divide them. Remember, this is the same thing. It's just different sides of the fraction. Or we can add or subtract, just going in different directions on the number line. And the order we do these is important. We want to do these transformations first and then do these transformations because bedmas. So our A values are multiply, and we're going to be multiplying our outputs there, A multiplied by Y. And then K, well, that's going to affect our inputs. But counterintuitively, K, we divide the input when we're transforming point by point. And then C's and D's, these are our addition and subtraction. C's add to outputs, so we're going to add those to the Y's. And D's, you just got to remember to flip the sign. D's a sign flipper. So just like a vertex form of the parabola, this is a sign flipper in the X and it's not in the Y. So make sure that you subtract that from X on your when you're applying these transformations. So we get these numbers from like the transformation form of a function there. And we're going to take a look at this example. We're going to start today with a parent function because yesterday we went ahead and went crazy with some crazy transformations to crazy functions. So here we have a g of x is a transformation of a parent function. So it's going to be a lot simpler. And how we're going to do this graphically is the first thing that you want to understand is make a list of transformations and what order they happen in. So let's go take a look at what that means that we need to do. So when I have g of x is equal to negative 2 multiplied by f of x, so this is negative 2, this is multiplying the output of f of x. So that's going to be multiplying my y values. The effect of that negative is going to reflect things in the x-axis, and that's going to give things a vertical stretch of 2. So I want you to imagine that. This parabola y equals x squared. It flips in the x-axis, then it gets stretched by 2. Then this d here, minus 5, that actually moves it 5 units to the right. Okay, so is that your right? No, it was your left. You're right. Okay, so moves it 5 to the right, and then the C moves it up 8. Okay, so we've got a list of our transformations. Now graph the parent function, and you can include some key points. So I just included points on this side of the parabola, but you could label any points you want. And then you apply the series of transformations in order. So the first thing I would do is my multiplicative one. I don't have any K transformations, just an A. So this is the only multiplicative one. I multiply all these points by -2 in the Y. So this one reflects and then gets stretched. This one reflects and then gets stretched. Okay, so this one maps down here. And these ones, of course, they're symmetrical in the original function and in the new function. Then I could apply my D transformation. So I'm going to add 5 to all of my x's because D was -5. So I have to remember it's a sign flipper, D. Sneaky D. Okay, so that slides everything, translates everything 5 units to the right. And now I just move all those points over. There we go. Then I can apply my C transformation. Raise it up. Every point goes up by 8. And so that moved that over there. Notice when I reflected this and then stretched it by 2, the origin mapped to itself. That's because zeros are indifferent to multiplication. I can multiply 0 by whatever I want, it stays 0. So things that are like your x-intercepts and your y-intercepts are going to map onto themselves with A and K transformations because of the nature of 0. So that's just a useful thing to remember when you're visualizing these things graphically. I really want you to visualize each set of transformations in order as you're doing the problems today. Try and see them in your mind first before you graph them. Then you'll build your ability to visualize these and see a solution independently of things like Desmos. Next, you can evaluate some of these points on your transform function just to make sure you got it right using the transformation formula we created yesterday. So here I had an A of -2, so I'm going to multiply my y's, and then I'm going to add 8 because bedmas. And then with x, I'm going to add 5 to those because that's a wacky sign flipper. So let's check it. 0, 0, indifferent to multiplication, so I don't need to worry about that. Add 8, and move it 5. Right there. Okay, so the vertex is in the right spot. And then this point, let's check this point, for example. Okay, so I stretch it by -8, and then I add 8 to it. Whoa, this should be up there, and then I move it over 5. 1, 2, 3, 4, 5. Okay, so that point checks out too. Okay, so I'm very confident in my work here that that's correctly sketched. And then you might be thinking, hey, Mr. Jennings, isn't that just the function g of x is equal to -2 x minus 5 squared plus 8? And that's significant because that's just basically our transformations there. And it's just another way of having something like, our y is equal to ax minus h squared plus k. This is just our vertex form of a quadratic. And I see here my -h, and I remember that's a sign flipper, just like that transformation was. And I remember k is the y value of the vertex, and a was my stretch factor. So from this form of the equation, when I'm looking at something like g of x is equal to -2 f of x minus 5 plus 8. This tells me where the vertex goes. This tells me the stretch factor. I can really easily graph parabolas in vertex form by thinking of them as a series of transformations, or vice versa. So I want to see the connections between those ideas right now, especially when we're looking at a graphical method, and see that. I could also have said, well, I know the roots, and I could have given you this in factored form as well with the stretch factor of -2. So you can explore connections there on your own as well. Now, we're going to now take that to another level. I'm going to bring you up here. So we've built the new functions equation. We saw that it could be expressed in vertex form very easily, and also from transformations. And next, if we knew that we had just created this function g of x here, what would h of x look like? If h of x were an a of -1, there's still no k values. I'm not playing with a k value today. X plus 3, so now this is going to be shifting in a different direction, and then adding 5 to the outputs. So here, make a prediction of what this one's going to look like. Try and and go through this, seeing it in your mind. We had that beautiful tall parabola that went up to a vertex of 5, 8. And imagine it flipping down, being reflected in the x-axis, being moved over 3 and now up 5 again. And around where would you think that you're going to find that? I predict that the vertex is going to be at -2, 3. What do you predict? Oh, sorry. 2, -3. I had my negatives backwards. Okay, so let's, I'm going to pause the video. Then you're going to do that one. And then you're going to check it against my work. Okay, so try that one. And then you can try the textbook questions. Okay, so I've quickly created a table of values here, or some significant points on g of x that I can just remember from the other graph. And then I can just work on each point individually. Let's start with a vertex. That's usually where I would start. So 5, 8. What I did here to create this was I just created a transformation point here, a little formula. So I made my y negative, and then I added 5 to it. So here, 5, this 8 becomes -8, and then I add 5, became -3. And then this 5, I can, I don't do anything to that. I don't multiply it, except I do subtract 3 from it, because remember, that's a sign flipper, so that goes to 2. So that's my new vertex. And I can do that visually too. I want you to do this visually, where you imagine it going down here, and then you imagine it being moved over 3 and up 5 to this point, 2, -3 right there. Okay, let's make a nice big vertex. Okay, and then this point here, I mean, it went right off of the map. It went up to 15, because when I made -10, +10, and then I raised it by 5, it was off my grid. So I can't graph that one. But this point 0, 5 I can graph, and it came from the point 3, 0. So let's work on this point here. I reflect it in the x-axis. It doesn't move. And then I move it 3 this way, so it goes to 0, and then I move it up 5. So it's right there. Yeah. So there's another one of my points. Oh, and why am I not writing? Oh, there, now I'm writing. Okay. And then I have this point, and I have another point here at 1, -1. So let's just put that one in. That's that point there. That's this point that got flipped down. See it in your minds. Moved over 3 and up 5. Okay. And then this point here, just missed that root and sharing that point, but they certainly intersect in there, don't they? And then this is symmetrical. So that's how I would graph h of x. H of x, and then find the new equation of h of x. But first we want to try practicing drawing another parabola. Oh, it's so hard. It's so hard with this technology, but I'm learning, and I'm practicing a lot today, drawing lots of parabolas. So will you. Okay, you can improve at your own things. So I want to create a new formula there. I know it has a stretch factor 2. It's opening upwards. I didn't stretch it any more or any less. It still has a factor 2. So this is, where am I here? H of x is equal to 2. And then this was x minus, and now I read the vertex, 2. So it's x minus 2. -3. Okay, that's a very complex way of graphing. X minus 2 times x minus 2 squared minus 3. But that's one way you can do it. Okay, thank you everyone for showing up for your learning. Try those practice problems in the textbook, and I'll show you back to where they were, and I'm just going to leave it on the homework for there. And then definitely make use of Mr. Feldman and make him feel right at home. I hope he already does. And so here you are. These are the problems. We will take these up tomorrow. And yes, I look forward to seeing you again on Wednesday. I very much hope. Bye for now, everyone, and have a fruitful math practice today, I'm sure.